Hey, hey. Just wait. Oh, oh, sorry, I was on mute.
No worries.
Let me see here. Okay, we live, and let me check here. Wait. Yeah, cool. Can you hear me, Matt? Hello?
Yeah, I'm trying to set up push to talk.
Oh, okay, cool. And let's see here.
Yo. Hey, hey. Have you been watching the 11? Testing. We can hear
Evan.
you. There's a feature called push to talk that I've been trying to set up, but I seem to be having trouble with it.
Fix my audio.
Nice.
Like the video.
Yeah, turn on yours.
Hey, I don't have a webcam actually.
What?
My PC here. I only have my my webcam built into my work laptop.
Oh, okay.
No worries. I'm just trying to show off Tom's beautiful face to the camera.
It's for Twitch channel.
Indeed, it's a business strategy. He's gonna be paid as a model.
Right.
A Twitch stream. Tom will be the next Twitch streamer.
That's your job.
Yeah, what's up, guys?
Hey, what's up?
Hey.
Oh, good to see you again.
All right.
How's your, oh, sorry.
No. We can continue catching up. Feel free to ask. What were you gonna say?
I was gonna ask Edwin how his Unreal Engine stuff is going. He might be AFK.
Give him a second.
Yeah, no, it's going well. So after this meeting, I'm just gonna go work on this some more.
What are you
Nice.
making in Unreal? It's trying to make like an RTS, I think. Oh, okay. Like a MOBA type thing.
I've been watching a lot of Unreal stuff, specifically relating to importing Mega Stand assets and using those, which are really cool.
Oh, that is cool. I don't really know much about that stuff, but I generally like watching people coding things on Twitch. I'm sure there's a bunch of people doing Unreal stuff there.
Yeah, I've actually only watched one thing on Twitch that was coding, and that was I guess the developer who created Nuclear Throne, which is a game I really like. And I watched him code it up live. It got kind of boring though. There's only so much you can watch to guide you for loops and if statements.
You can't really. People that manage to make it exciting are definitely talented in that way because it's crazy.
Yeah, that's a different. That's a certain kind of talent. Seeing something that's not meant to be watched and making it so.
Where's Lee?
Oh, Baron. Do you guys like watching people? So you were saying that it kind of gets boring watching people stream coding.
Yeah, it can definitely be, especially if the guy's trying to figure out something and it takes forever. Like it kind of like watching paint dry.
Yeah. Yeah. I mean, so we stream our stuff, and part of the question is like how much to do it live, or how much to do it beforehand.
Like if there's a good flow to it, it's probably okay. But I don't find that. I guess I might be different from other people, but I don't find that I can learn very well from watching code being typed on the screen. Like I sort of get it, but I have to kind of sit down with something and then like actually be typing myself.
Totally agree.
Because then I'm like I watch someone code and then like later on I'm like, wait, what did he code? What did I just watch? What's going on? Like you don't really know.
Yeah, it's impossible.
So I've also
it's good background noise.
Yeah, as background noise, I think it works, and I think that works for like Twitch streaming or Twitch gaming as well. But I think for like live coding, it's like for anything, it's always easier to read an article, right? It's always just easier to be like skim through an article and come back to it.
At least for me personally, I found the most effective way to learn a code base or present code is interleaving code snippets with like paragraphs of explanation. So you just have a code snippet, then you go through it, code snippet, so on and so forth. That's best for me.
Basically, medium.
Yeah, medium is like probably the best format, I think. It's like, yeah, problem. Here's a code snippet. Here's what we tried. Blah blah blah. Use some variables. Here's what they mean. I think that's probably the best way.
Well, Matt, I've been putting together a proposal doc at work to get us using DBT because I tried it out myself over the weekend, and I think I'm converted. I think it has like some real big business implications.
I
or
think it's one of the
applications,
easiest
rather.
ways to get business people to write code, and it's one of the easiest ways to integrate SQL and Python.
That's
I,
exactly what it is. It's just easy to use.
And I think that's great. I don't like some of their architecture decisions. I don't like their folder structure. Um, I don't like how you declare a lot of things in YAML files as opposed to declaring things like if you're trying to declare the type of the tables, like the column types, you declare it in a YAML file as opposed to just declaring what your create table schema should be. And it's like, why not just let me write that code myself if I don't want it auto-generated?
I completely agree with that. There really are no like create table statements. Really, they're all just like selections.
Yeah, well, so if you look into the compiled output, you'll see all of the create tables.
But I think it's strictly like data manipulation language. Like, they don't even let you handle all the DDL, like good and bad, like you said.
What is DDL?
Yeah, I forget what the actual D is, but DDL is just like create table statements, create view, like those kinds of statements, and ML is more like select from here or there, do a count, do an average into like a new table or something like that.
Yeah, so I mean, we're probably going to touch on a lot of it in today's lecture, but I generally think if you do like an event-driven architecture paradigm, you'll have the only thing that is not like a derived table is going to be your events, and then everything else is just going to be derived from that. And so DBT is a tool that actually works within that paradigm very well, and that's particularly why I like it. But I could imagine if people don't adopt these paradigms, then they probably pick different tools.
I think what's even harder is just like potentially integrating it into a new system, into an existing system.
Hey, Jatin, you're in the wrong room. Oh, sorry. Come.
Tom, I'm going to mute you for a second. All right,
cool.
Yeah, integrating it with new systems, yes. So part of it like is what you'll find like you have a lot of the same stuff in different places. Whereas if you started with DBT from the ground up, they're all about like reusability of SQL statements, so you won't have as many. Whereas nowadays you'll have like usually there's just so many SQL calls that you use to a database. So if you're like trying to transport your ML model into DBT, which I'm actually currently doing at my work, you'll be like, wow, I have like all these SQL calls that are basically always creating a new table. And that's not really using the power of DBT, because the power of it is that you should kind of have generalized tables. That's like, here is this type of object that I use. And then everything else that wants those objects should kind of be its own table derived off of that table.
Totally. I mean, yeah, it just kind of forces you to think about things differently, which is really cool.
Yeah.
But I think the way that we have business people write SQL now and how we integrate it into the actual database, DBT offers a way more accessible avenue for that.
Yeah, so I think that was back to this point, and we'll touch on something that we mentioned last time, which is the goal is to try and get away from SQL as quickly as possible. And I understand why a machine learning engineer would say that, but I think SQL is the best language for business people. And so I generally try and get business people to strictly stay within SQL, and then the whole how do you get SQL to Python is the big challenge. And so we'll end up talking about a lot of that stuff. Anyway, I guess I'll start to kick off what today's lesson is. So yeah, generally today is going to be two things we're going to do. We're going to keep with the coding exercises with Edwin. So I'll kind of follow along that just to get some coding in. And then afterwards we'll have a sort of like general purpose, um, coding discussion. And so we'll structure it a little bit. I've been thinking about how to structure it, and generally, I think there's some ways to organize it, but it's one of those things where I think the conversation is going to jump around so much that we'll sort of do our best, but eventually we'll just kind of let the conversation go from there. And the topic of conversation there is going to be like, how do you build big data engineering pipelines, big data engineering processes, or how do you actually think of working on like a big project, and what tools should you be considering, what sort of paradigm should you be considering, and things like that. Um, yeah, and then from like a logistics standpoint of what's going on with this organization, we talked about how we've been trying to grow recently. We talked about how we've been trying to figure out exactly what our little niche is, and I think these discussions kind of might be a good place to stick to for that, in the sense that maybe online coding isn't the best thing, as has been mentioned already today. But discussions online, I think, is great, and having like discussions with your friends around good engineering practices can be also enjoyable. So there's that. All of these things have sort of been focused around people that have been coding for a while, and so a lot of the things have been use like advanced terms. We naturally try to explain things as best as we can or as clearly as we can, but there's still this kind of catering towards a little bit more of an advanced crowd. So one of the things we're considering over time is doing things a little bit more from the ground up. So like, how do you write Python code from the ground up, right? How would you run an actual machine learning model all the way, if you have zero experience, all the way up to that? That's probably not going to occur within the Wednesday formats, simply because of like the crowd we're trying to cater to, but it's definitely on our minds, and it's definitely something that we're thinking about how to do. And that is about it in terms of announcements. Can't think of anything. If anything, I'll kind of bring it up at the end. And as always, if anyone has any suggestions, please reach out. And I'll definitely be reaching out to everyone over the course of just as things go on. Okay. Edwin, are you there?
Yes. Are you ready?
Yep.
Everybody
Yes.
ready? All right. So let's get started. Yeah. I'm streaming now, and yeah, to echo what everybody says, I don't think it's helpful if I spend like an hour walking through my thought process and coding everything line by line. In the sense of explaining every single intricate detail, because obviously this is something that it's not a spectator sport. It's something that you have to do by yourself, and the way I implement it is not always going to be the best way, and also the way I implement it is it also I already did this problem like an hour ago, so there are certain like challenges that you didn't see me go through, and it seems like I've contrived everything out of my head, but that's certainly not the case. So that's why it's not very an effective medium for me to spend in essence trying to go through every single little detail, and you really have to do it yourself, and then you'll understand the choices I've made, and also why certain things pop up frequently and why certain things don't pop up as frequently. But yeah, in the interest of time, I definitely don't want to impede the discussion too long, so I'll only take 15 minutes for this problem. And hopefully you've taken a look at this problem. It's a very famous problem. I understand everybody wants to have more practice with dynamic programming. And this is a great classic dynamic programming question called n queens. And this question asks, given n queens, or let's say 4 or 5 or 8 or 9 queens on a 4x4 chessboard, so let's say it's 4 queens on a 4x4 chessboard, how do we place these 4 queens on this 4x4 chessboard so that no 2 queens attack each other? So if you're familiar with chess, you understand a queen can go anywhere. They can go row-wise, column-wise, and also, of course, diagonally. And you can see in this example, what we have is we have 8 queens on an 8x8 chessboard, and you can see that each queen is not able to attack each other. So our task is to devise a board just like this, just given the number 8 as our input, or 4 for a 4x4 board, or 5 for a 5x5 board. And you can see here in this example, given an input of 4, you have a 4x4 board, and you can see this mock chessboard where a Q stands for queen and a dot stands for empty tile. And you can see there's 2 possible solutions, 2 distinct solutions where we can place these 4 queens on a 4x4 board so that none of these queens are attacking each other. So in terms of dynamic programming, as we really talked about like ad nauseum, you really have to think in terms of combinations and trying out as many different combinations as possible in such a way that it will give you a complete solution to the problem that you're looking for. And when it comes to building out these combinations, it's always helpful to start out small. So let's say, for example, in a 2x2 board, can we place 2 queens on such a board that they won't attack each other? So let's say that there's a 2x2 board, and then we place a queen here, and we place a queen here. That looks like it may be right, but remember that queens can't be diagonal from each other as well. So in our solution, we have to, in essence, we have to make sure that we have to check that queens are not in the same column, and queens are not in the same rows in terms of being able to attack each other, but also in terms of diagonal, that they're not being able to attack each other. And given this example, we can see that a 2x2, given an input of 2 queens on a 2x2 board, we're going to have to return no solutions. However, for a 3x3 board, can we actually have a possible solution for this? So when I always think about dynamic programming, always start small, and then we can always build our way up. Well, let's assume that I put a queen here, and I put a queen here. This seems to be legal so far, so I put 2 queens so far. Can I put a queen in the 3rd position that allows us to not attack the other 2? So that's the question we have to answer for a 3x3 board. But you can see how this pattern is growing and how we're thinking about ways of trying to, in essence, try to find out what is the recursive solution that of all the combinations that we have to try. We have to make sure that when we place a queen on the 1st row, a queen can be placed on any position on the 1st row. And then when we go on to the next row, we have to make sure that whichever position that we put the queen on the 1st row, we have to try out every single combination of every single queen in the 1st row against all possible combinations of queens on the 2nd row and all possible combinations of queens in the 3rd row. So hopefully that makes sense. But you can see how this has become a real iterative problem. And because we're calling the problem itself, we can also turn this iterative problem into a very intuitive recursive solution. But of course, every single recursive problem can be implemented iteratively. But I think let's do a recursive implementation since they're more intuitive, I found, and also they're more fun to do. And I think everybody needs more practice with recursion. So, given the solutions, it seems like the output is a list of strings. So what we expect is our solutions expects there to be a list, and we have to return a list of possible solutions. But then each solution itself is a list. So how do we get started with this? So because we're thinking of doing a recursive solution, and we're thinking of, in essence, traversing every single row in order, this is actually a depth first search problem because it's recursive, and we're going through every single, let's say, we're going through every single row and trying out every single combination in order, and we're incrementing, and after we're done with the 1st row, in terms of all its combinations, we're going to try out the 2nd row to see all the possible permutations with a 1st row. So given that, we're going to call this, we're going to implement a depth first search problem. And here's the kicker too, in terms of we don't actually have to implement the full matrix as well, because as we know, we can't put a queen. A queen can't. You can't have two queens on the same row, right? So the only difference is in when constructing this board is all we have to know is that we only care about the columns really. We can actually put everything in one list because queens can't be put in the same row. So we only care about a list of possible positions of queens where let's say this is one. Oops, I think I accidentally refreshed here. But let's say we put a queen of position here, 5 and 7, or let's do 3, and so on and so forth. So we can actually represent the chessboard as one single list where a queen will be placed in column 1 in the first row, and then in the second row it would be placed on column 5, and then in the third row it would be placed on column 7. So we're actually having the index position double as the row number. So that's a very neat trick, so that we don't have to construct the full matrix in order, because we know that each queen has to be, as you can see in this image here, each queen has to be in their own independent rows. So we only care about placing queens on the right column, if that makes sense. So our task is, given our board, we know we have to place each queen on each of their own rows, but we have to make sure that the column that we place this queen in does not conflict, as you can see in this 2x2 example, does not have a diagonal position with a previous queen, and also, of course, is not in the same column as the previous queen, as any other previous queen that we place on the board so far. So we're going to construct a mock list of the column positions. So given, let's say, a 4x4 example, this list will only be 4 columns, and then that will be our board, so to speak. And then of course we're going to start in row 0, the first row, and then we're going to have we're going to build the path for every single combination. So when we're trying out one combination of one possible solution, we're going to be adding on to this as a possible solution. And of course, we're going to, if we find a valid solution, we're going to add it to our list of solutions so that we can return all of our solutions, as you can see here in this expected output at the end. So let's unpack. Essentially, let's define this depth first search. And depth first search, I mean, it may be confusing because this is essentially a graph kind of problem, but it's also a very simplified kind of graph problem. So if you wanted to call this like place queen, or call this function like place the next queen, I think that would actually make more intuitive sense. But you'll see, but I think it's useful to call it depth first search for now, because what we always expect is that patterns always tend to crop up, and when you do enough of these problems, you can see that depth first search comes up in a lot of problems, in graph problems, in dynamic programming problems, and so on and so forth. And you can actually implement this fairly quickly once you have enough practice with it. So we're going to call this solution from far, and then we're going to call this solution. So let's implement this. So if our row, right now we start at row 0 in terms of all our first combinations, and then we're going to check if this is equal to the length of column. And if this is equal to the length of columns, then we've hit the end of the board. So if the row number, once is in our recursive implementation, if we first start at 0, and then of course in recursion we always go to the next part, that's a smaller subset of the original problem. We're going to go to row 1, then row 2, and then once we hit at the end, when row is equal to the length of columns, when in the 4x4 board, when n is equal to 4 and row is equal to 4, and it's equal to length of 4 columns, we're going to hit the end. And if there's been no errors or no return falses, we're going to know that we have a valid solution. and we're going to append our solution so far to our solutions list that we can return at the very end. Okay, so that takes care of the base case. So now, in terms of the actual recursive step, what we're doing now is we're going to loop through every single column in the columns so far. So let's just try for a 4x4 example, since we already have this, we already are given solutions for them. So let's just start with the input of n equals 4 on a 4x4 board. So for each column, for column 0, column 1, column 2, and column 3, for what we want to do is, as explained before, we want to make sure that given the current row position that we're on in row 0, the index position doubles as the row number. So we know that we're going to place the column in this row index position of 0, and we're going to place this column let's say we start off the column 0. We're going to place the column 0 in the row position 0, and that would essentially be our first solution. So the queen will be placed on position 0, or the first position. And then we're going to keep on going back forth. And this essentially means that we're placing the queen on the right position on the certain column. But now we need to check to see if it's actually valid so far what we've gotten. So we're going to make another function we're going to call it check valid, and we're going to pass it the columns that we have so far and the row that we care about. And we're going to write this function later, but we're just going to stub it out. So of course, if it's valid in terms of the current combination that we're on, the current path traversal that we're on, we're going to make a new row, and we're going to, so LeetCode expects us to make, every time we make a new row, we have to make a string of periods. So we're going to have to do the length of columns on a 4x4, so we have to make the dot 4 times. And then after we construct this new row, we're going to do another depth first search, of course, with the same columns that we have, with queens pre-appended on previous rows that we've already traversed. And then, of course, in a recursive solution, we always want to go on to the next row, the smaller subset of the universal problem we're working on. And then the solution so far, we're going to append this new row that we've created that stops at the column that we've decided that is a valid placement for the queen, and then we're going to place the queen here, and then place the new row here, and then the column. We have to make sure we're not putting on the same position as the queen, as the Q, and then we're going to end it there. And that is our solution so far in terms of what we expect. And then we're going to, of course, pass on the solutions that we built so far in the depth first search. So this is what the solution looks like in terms of, seems like we've done, I did a lot of, it seems like they're considering this as one line, which it should be, but this is gone too big, so let me minimize. Okay, so now it looks better. Okay. All right, so now let's actually check to see if we can place the queen on that valid position. Okay, these indentations, okay. So let's actually define the check valid portion, and this is really the heart of the problem. I guess the depth first search is, that insight is very important, but we're going to check to see whether we can place the queen on that certain column. So if we can actually place that queen on that row, on that particular row, and then in terms of checking whether it's valid, we want to loop through, I'm going to call this inner row, and for every single row. And then we're going to check if this queen that we're going to place on this row that we're on is on the same column. Check if this queen is on same column as previous queens, right? And we do if columns. We're going to check every single inner row of all the rows we have so far. If that is equal to columns of our current row position, then we're going to return false. It means we cannot, this is not a valid position, and we have to return false for this particular combination. So we have to try the next rows in the next columns. Okay, so we also have to check the diagonals, if you remember. So we have to check diagonal. And we don't have to, remember, we don't have to check rows again because we're doing everything off of one list. So we already made the key insight that each row, each index position which we've assigned to be the row position, each queen is going to be in their own row. But we, of course, have to check diagonal, that queens are not placed on the same diagonal. And the mathematical trick for here is that if the column distance is equal to the row distance, we know that the two queens are on essentially the same square, and they share the same vertex, and that means they're on the same diagonal. So let's actually implement that. So the column distance is equal to the absolute value of the columns we have so far for the inner row minus the columns on the row we're currently on. And then the row distance is equal to the row minus the inner row. We don't have to do the absolute value here because remember, we're looping through every inner row to be the row. So row is always going to be greater than the inner row. Greater than, yeah, so we don't have to worry about absolute value there. And then if the column distance is equal to the row distance, we know that we're on a diagonal, and this is an invalid position that we have to return false. If it passes these two checks, then I'm not sure. Okay, so if it passes these two checks, then we can return true. Okay. All right. So that's essentially what the problem is asking about. So we're going to do a depth first search starting at row 0, and if we're able to hit at the end that the row is equal to the length of columns, we have a valid solution, and we're going to append it to our solutions list and return it. And while we're trying out every single combination, we're going to loop through every single possible column, and we're going to assign, in this particular position, the column that we want, that the queen should be, of course, like placed on, like, say, on a 4x4 example, they can be placed on the first, second, third, or fourth column in each of the rows. And if this is a valid position, then we're going to add it to, we're going to add the 3 dots in the queue into our solution so far, and we're going to keep building up that solution. And if it's valid all the way and doesn't return false at all, then you know that this is a valid solution that we can append, and then we can try out the next possible solutions if they exist. So this is what the problem looks like. I'm going to try running the code, and hopefully there isn't invalid syntax solution so far. I think I just probably missed here. I wonder what probably is like a list, a new column row. Oh yeah, this is a rookie error. We're going to add the column here, and then we're going to slice it there, and then hopefully that will work. But yeah, if there's any questions, this is what the the answer looks like.
So I thought this was super interesting, and the particular part that I think is why I think it's really interesting is where you decided that you can basically say that define it as a row of numbers where each the index of the row represents the column and the value in the row represents the row, or vice versa. Because originally when I saw this problem, I was like, okay, how would I solve it? I'm trying to think in my head, and I actually didn't get to that conclusion. But I think that's like one of the more powerful conclusions. More so, if this problem was like, how do you place 8 rooks, or how do you place n rooks? At that point, you've already solved the problem. You've basically created another problem that is an equivalent of the problem you're discussing, but has like a limited amount of space. And I think that kind of touches on like the mathematical side of computer science, or of like solving these problems, where if we're essentially mapping one problem to another problem, and we can solve this other problem, then we can solve our original problem in a very simple way.
Yeah. Yeah, it's this problem, like, it's a hard problem in LeetCode for a reason, and it's a very classic problem because, let me give it a like too. It's because not only are you have to juggle the recursive depth first search, and so, you're trying out every single combination in turn, but you have to check inside your traversal. You have to check whether each position is valid. Whether the current position that you're trying to place the queen on, is that a valid row? Is that are you making sure that this queen is not on the same column as prior queens and doesn't share the same diagonal as prior queens? So that's why this problem is so that's why I would recommend, if you're still not really grasping this, I would recommend doing medium or easy problems where you just care about the depth first search, and you don't have to check whether each position that you're placing the new element on, whether that is a valid position or not. And so the only thing you're juggling right now is the depth first search. And the reason why this is a hard problem is because not only do you have to juggle this portion, but you also have to juggle the validity check.
Yeah, that makes sense.
But yeah, like, if this is new to you, like, depth first search is a common pattern that repeats itself. So once you get familiar with the depth first search, you'll see that you will see a lot of graph problems and dynamic program problems are just extensions. Like, this problem is just an extension of the depth first search problem, because we're not going through a matrix, but we're going through a list, and we're doing the check valid. But besides those two things, it's really this is a really classic pattern that you'll see repeated over and over again. And the reason why we did this recursively instead of iteratively is because you could have done this iteratively. You could have just made a stack, and you could have just looped through the stack and keep pushing on to the stack and check every single combination that way. But this is a lot more, once you get used to it, a very intuitive solution, because you don't have to worry so much about trying out every single combination and holding it in your head. You're letting the computer take care of the details for you, because when you say, just let me do a depth first search and let me recursively do a depth first search again, I'm trying out depth first search for every single column. So you're abstracting away that implementation detail of checking every single possible combination to the computer. You're just saying, yeah, for every column, I want to do a depth first search on the next row. So you can see how the computer is going to try out every single possible permutation for you.
So I think that's also another good point, where like this problem can actually be solved by literally coming up with every single way to place 8 queens on a chessboard, and then doing a validity check on all of them. But you set up the problem in such a way such that you don't have to do horizontal and column checks by simply setting up your problem in the right way, and then all you have to do is check for the diagonal. I think that's super interesting.
Yeah, well, you have to check. You have to check if it's because we're placing the queen on the next row. I mean, so every single index position as we're looping through the columns, we just have to check it to see if this queen is going to be on the same column as prior queens, and then of course checking the diagonal. But so we have to do these 2 checks here. But yeah, we don't have to do the check row here because of the way we set up the problem.
Interesting.
Yeah. But yeah, that's it for me. If there's no other questions.
It doesn't look like anything. Oh, Tom?
Can you guys hear me?
No? Yeah, you just unmuted.
Yeah, you just unmuted.
No, I'm good. I'm good.
Okay. All right. Well,
Thanks,
you.
Edwin.
That was a really cool problem, and I had a great time listening to it, and I'm sure everyone else did. Awesome. All right. Let me open up my situation. Yeah. So for the rest of it, we're essentially going to discuss like different data engineering tools. Evan and I were talking earlier. If you were online, they'll probably touch on a bunch of them as well. So let me kind of share how this is going to work. Essentially, the way it worked last time is we kind of brainstormed a bunch of topics for a potential outline. And then from there, we kind of just went through the outline one by one and talked about the different things, right? So talking about data engineering, like a few things immediately come to my mind. One is like languages, right? So you can kind of have languages that you can pick. Not all languages are great for it, but the few that pop out are like Python, SQL, and probably Scala as well. Scala. We could also talk about like tools. We've talked about Airflow is an important one. We talked about dbt a little bit. I think that's an important one. I think software architecture is also important. Talking about one of the things that I like to talk about is event-driven design, which is an architecture paradigm. I'm also going to mention Lambda architecture because I've seen a lot of articles. I think it aligns very well with event-driven design, but I don't know quite enough about that topic to talk about it, but I'm sure we will sort of touch on it. Are there anything, what else can you guys kind of think of as like topics to talk about in the context of data engineering?
Context of data engineering, probably should address Spark and tools like that for handling large data sets.
And database tools. I feel like databases should really be its own thing. There's so much to say.
What are they called? The what's the
ORMs?
ORMs, yeah. That's what it is.
What does it stand for?
Nice, man.
Relational mapper.
Say again?
Object relational mapper.
Oh, that's going to be an interesting one. People have very strong feelings on whether or not to introduce an ORM.
I think I'd also add like intermediate storage tools like S3 services are just like part of the workflow. Like how
S3 can be final storage. I don't know about intermediate storage.
Okay, S3 can be final storage. Like I query directly from S3 with Snowflake all the time.
Or Glacier. Glacier is probably like where data goes to die.
That's that.
We're totally gonna access this data later, guys. We're just gonna put it on ice forever.
Oh, is that why they call it Glacier for the cold line storage?
I think it's Glacier because you're technically not supposed to defrost it ever. You just put it in there. You pay them money, and then you pay them an egregious amount of money if you ever want to access it.
That seems
You'll
like
be pretty sure you're not touching that data ever, but you got to be like a hoarder and you can't get rid of it.
Yeah, I wonder what the ideal use case for that would be.
For law firms, they have to keep data sometimes for a decade or more. I mean,
Or
you want to go
manage
back to
for
it. Yeah.
contingents.
Yeah, back in the day, used to be called tape backups when to take it for all historical government-based stuff, where you had to go back, history, archive it, you never touch it unless there's a major query or something.
I think recently Kafka and replayable streams are an interesting tool. Any other high-level things that this might go outside of like languages, tools, databases, architectures?
Commercial out-of-the-box solutions for ETL, like well, I don't know, some tool like MuleSoft, Illuma or whatever that startup is that charges lots of money for ETL. Just things that people default to when they don't have, I guess, a data engineer or they don't want to create a custom solution. Informatica is another ETL tool that's widely popular in a corporate environment.
Yeah, Informatica, so that's right.
I'm almost tempted to add Excel as like a.
Oh yeah, I mean if you're at a hedge fund or investment bank, they just love to do it in Excel. My God.
Yeah, I mean it comes with its own problems, but I think
It's a portable database and you can type stuff in it, and
yeah,
it's great. You can just do VLOOKUPs for the rest of your life.
Yeah.
I'm a little bit salty. Sorry, I have to do Excel and I don't like it.
Have you had to do VBA? VBA still works.
Yeah, I'm still waiting for them to integrate Python to replace VB in it. It's like that was promised a while ago. I don't know if we're happy.
Yeah, in 1984.
Yeah, there's also in terms of communication networking protocols like REST, gRPC, GraphQL, your favorite, Matt.
Oh, data interchange formats? We should talk about Arrow then, probably. That's one of the latest developments.
Data interchange formats.
Yeah. How do you actually send large amounts of data over the network? What's the best way to do that? Is it you just pack everything into a bunch of TCP traffic and send it over? Probably not. I don't know.
Curious what Arrow is, but we'll get to it.
And RPC calls remote.
Yeah, remote secret calls.
Yeah.
So this is a conversation up higher.
Yeah, I also feel like what type of application it is. Is this like a web application? Is this a mobile application? Is
Like
this
the client interface.
well, not. I mean, like right now, I'm spending a lot of time on game engines. So it's like, okay, how does a game engine fit with all this stuff? Right? Yeah. So that's like that's so
interfaces.
So it's like what kind of like product is this? What kind of stack is this?
But there's other ones. I feel like would like Bash be no? I guess that kind of goes into the data interchange format conversation. Okay. Anyone else want to touch on anything? We can always add things in as they kind of come up in conversation. And I'm sure as we touch on some of these higher level ones, we'll kind of flesh out a little bit more down below. Okay. So the three big languages are I think the two big languages are Python and Scala. Those are kind of the big tools that you're going to be using across the board. My biggest question is kind of, is there a clear way of figuring out what logic should be in which of these two? And I want to go so much as saying yes, saying that SQL should be business logic and Python should be engineering logic. I know that's generally like a hard stance, but I think it could be a stance. I don't know if anyone has thoughts on that.
So repeat the question. Sorry, you broke up for me.
So I'm generally like my question is, can we create a good distinction of when to use which language? And my suggestion of what that distinction should be is that SQL should generally be a business logic language, whereas Python should be a engineering language. And so that, in my mind, is kind of a good way to interface between the two.
I think it highly depends on what you're trying to do. I mean, SQL has a very good purpose. I mean, if you need to do it just wildly depends on what you're trying to do. I think, like, I think it's a mistake if you're, for example, if you're pulling stuff into memory on a machine and then manipulating the data in Python, where you could do something very similar just using SQL. I think it's a lot better to let whatever database engine that's probably coded in C++ do that heavy lifting for you than it is to be manipulating a data frame in memory wherever possible. So for me, it's like the first thing is, can I do this in SQL? Can I make the database engine do the heavy lifting for me in this case? Or is it better to actually do it locally on whatever machines I'm putting data into?
So
That's
wait,
definitely true.
SQL is faster than Python?
Oh yeah.
Oh yeah? Oh, okay.
Oh, yeah. By a lot. I mean, it really depends on how much data you're talking. Even if you're talking about a lot of data, Python is highly inefficient in terms of
Speed.
it's an interpreted language. It doesn't. I mean, I guess it depends on how what you're using, how you're storing the data in memory. But it can be like if you're creating plain old Python objects to store your data, they're probably allocating way too much memory for that.
Oh, I see.
So yeah, for example, like let's say you're taking, I don't know, let's say 100 megabytes out of a database. It takes up 100 megabytes in the database file, probably stored efficiently whenever the database loads it into memory to send it over to you. And let's say you're loading it like a good data engineer or a good data scientist loading it into Pandas, and you're not taking advantage of any of the optimizations that Pandas offers because, I don't know, maybe it's one-off, maybe you don't know about them, maybe whatever. You load that 100 megabytes into Pandas, by default, automatically, you're just going to have 10x that memory footprint. So 100 megabytes turns into 1 gig, all right?
Oh, I didn't know that.
In memory. I mean, I think it might have gotten better over time, their memory footprint, but I know from experience that, like, you take the 200, 300 megabyte data set, put it in Pandas, and suddenly, I guess it depends on what the data set is. If it's mostly strings, you're left scratching your head as to why you're out of memory all of a sudden. So it really, really depends on what you're trying to do with it, but it can be very inefficient. And then you have to consider network as well. I mean, you're transferring this large data load over the network, and maybe by the time that it's transferred to you, you could have had it finished on that end, and it might be even a smaller data set if you're aggregating, and you can just transfer that smaller data set over. So it's highly dependent on what the problem is, whether you want to make the SQL engine do it or whether you want to do it yourself.
Oh, cool. Thanks for
Do you
clarifying.
have like a good distinction of what that like a good rule of thumb? Because in my mind, I think if SQL can, like, there are a few problems with SQL, right? It's hard to test is one of the big ones. Generally, you're not as flexible as other languages. You don't have like you don't have imperative commands, so you can't have like state within the actual execution. You just have. and so you can't like do anything literally in the middle of it, right? So
Yeah, unless you're in T-SQL, right? So if you're working for Microsoft Shop and you basically live within SSMS and Microsoft SQL Server, then you do have access to a sort of weird combination of programming in SQL, because you can store state and you can do if and for loops within a stored procedure within the database, within a transaction, which is weird because I mean nobody learns SQL that way, and I personally don't use it in that way, but you can do it in that sense. I don't recommend it, but I mean, what's efficient in a database? Filtering, efficient, can be efficient. It depends on how you index. Depends on all of these constructs that you put in place around your tables for performance benefits, right? So I mean, you can create tables, but then you can do all this other stuff surrounding your tables that is highly that is for optimization, for dependent on your usage of said table. So if you index this column but not this column, you'll have better performance there. If you structure it this way, if you create a cube out of your data, you'll have great performance in certain situations. If you create materialized views, pre-aggregate certain columns, you'll get performance there. So there's a lot of things that you can do to keep the processing in the database or make it more efficient. Generally, filtering probably should be done inside of the database. Databases are also good at aggregation. What sometimes one of the slower operations, I think, is probably window functions and going through groups of rows like that. I haven't found them to be particularly performant in many cases, but also if you try to take the data out of the database and then form windows in memory, that's also not going to be very fast. So sometimes you just can't win. I don't know. I think filtering, aggregation probably should be left up to the database.
yeah, I will. So I think on the point of window functions, now I was going to mention something about caching, but I guess that doesn't actually apply to window functions.
Yeah, window
well.
functions, it just sucks when you have to go, when you have to shift the frame around and go through an entire data set like that.
Yeah, but is there like pulling that to Python? That's not even going to be faster, right?
No, because then you suddenly you have the networking cost, you have the transformation cost from getting it from the buffer into memory, and then you're beginning that whole process. Sometimes you maybe can't even fit the whole thing in the memory at once. And what do you do?
Do you think if that wasn't the case, Python would be faster? I almost feel like
no, it's Python is almost never going to be faster.
I mean, even a performant language like I guess Java, Scala, or whatnot.
I haven't performed tests on that, so I can't really say. If you're asking me if like I mean it would be hard for me to contest, like for example, let's say that somehow or for some ungodly reason you wrote something in C or assembly to do some performance scan, then I would be hard pressed to tell you that it's not going to be more performant than the database. But with Python, I can tell you probably not. And since it is the language of choice for a lot of data engineering, you got to be really careful when you're pulling data into and out of it, where you can use a sufficient database that has been designed and tested over a number of years to do this exact thing.
Okay. Well, so given Python and SQL, are these languages going to last in the data engineering pipeline?
Oh yeah.
Why?
No doubt. Mainly adoption, continued usage, especially SQL. I mean, it's been around forever. There have been, I guess, numerous provinces that NoSQL and other interlopers were going to kill it. Nobody was going to use SQL anymore. And that hasn't come to pass. In fact, I think there's a lot of people that are very comfortable with SQL, and it does a very good job with relational data sets. It's not the right solution for all data sets, but it's particularly good for financial data. It's particularly good where data is highly relational. Python, on the other hand, I mean, Python can be replaced. It's just easy to learn, easy to use, highly interactive, so it's great for developing things quickly. It's take great feedback. For example, if you're a data scientist and you're building models, it can be very interactive. You don't have to wait for compiling or anything, and you get instant results back.
I like Python as like, I think it's the best first language for anything, simply because it really gets out of your way for just about anything.
Yeah, it's not in your way, right? But I find that with Python, it can easily come back to bite you like 3-4 years down the road, right? So you're prototyping, you're building stuff, everything's going great, and then suddenly you're a more mature company, or your project's more mature, and maybe you're handling increased loads, increased data sizes, and I guess maybe the way that you prototyped or you used it, and the ease with which you code in it, has produced a code base that is no longer suited for the current situation, and then you're not struggling to optimize within Python. That touches on a couple of points, but I think that the ease with which you can code in Python also lends itself to putting you in situations where you're struggling for performance later on.
So that's why I sort of like the distinction of trying to keep business logic in SQL, because if you use Python just for your engineering logic, at that point what it's responsible for is generally kind of like orchestration type things. And so if it's doing that, you can almost like if you're orchestrating a SQL read and then write to cache, and then generally you start just serving that cache to whoever's looking for you, right? So at that point, your Python's doing very little work, but the work it's doing is kind of the glue between all of your other applications. And so I don't think at that point you'll have those same scaling problems.
Yeah, probably not. Well, I mean, if you're, let Edwin go ahead. Edwin speak.
It's just something you said, man. It's like business logic in SQL layer. I know you, Lee, and I have discussed this, but it's just not I'm not a big fan of putting like any business logic in the database layer. It's just not what SQL really is intended for, and it also removes all the gains of object-oriented programming since it was invented since the 80s. It's just not the way to do it, in my opinion, in terms of developer productivity, and also in terms of not even in terms of performance in a macro sense, because it's very hard to spin up new database instances, but it's very easy to spin up new application layer instances. So that's also something to consider too.
There's some technologies that challenge that, actually. I mean, if we're talking about Postgres, sure, or Redshift even, like that, it's gonna take a while for you to spin up new instances. But if you're talking about something like newer, like Snowflake, well, they have a lot of abstraction layers between yourself and database instances. So they essentially, I've worked with it a little bit, but they make instances available instantly to you and scale instantly because they have these running in the background 24/7. It's extracting from you. So there's some developments there. But I mean, can we get a solid example of business logic in the SQL layer?
Like, great question.
I mean, let's say you had, say you're in financial services, right? You have a series of transactions, and then you're trying to aggregate by day, right?
Mm-hmm.
So in SQL, that'd be like an aggregate function. In Python, what you'd probably do is put it in a pandas data frame, and you do an aggregate there, right? So the question is, where do you want that like little snippet of logic that I just talked about?
Yeah, I mean, for that, I would 100% put it in SQL. That's because one, it's inefficient to put it in pandas, and two, because I can, at the SQL layer, I can create a pre-aggregate of that, so that whenever the data is loaded, it's automatically pre-aggregated along that dimension, and then it can just be accessed in that way. No computation needs to happen, especially if it's used on a daily basis. So, say you have a table and you're aggregating by day. Now, if you create a view on that table, and let's say you have daily loads into that table, well, now that you have that system set up, you have the table, you have the view created on the table. Now, whatever ETL process is now either copying or inserting to that table, that view is getting automatically updated as that table is. Presumably, there's some database systems where you need to recreate the views, some that allow for updates as the data is inserted, so that everything is sort of lockstep, and you don't have to intervene. I mean, and I agree it's annoying that if you create this whole SQL layer structure and it doesn't automatically realign itself whenever you insert data, that's a little bit annoying. But for something like that, for aggregates, I think their place is in the SQL layer.
Hey, just one moment. Hey, Matt, someone is telling here on YouTube that C++ is much better as a first language.
Who's saying that?
I don't know. It's just someone. That person is not logged in, and I cannot see his name.
Where are they? Are they in text? Or I can't see anyone.
No, it popped out on YouTube, so it's.
Oh, wait, YouTube.
Hi to YouTube.
Matt, you gotta have all the chats stacked up next to each other. You gotta have,
I guess I should have done that.
You gotta have Discord chat, YouTube chat, Twitch chat. Can't miss anyone.
No, but Matt is busy writing, so that's why.
Matt and Andre, can I jump in for a quick question?
Please go ahead.
Can you hear me well, by the way?
Yeah.
Okay, great. Thank you so much for conversation. It's really helpful for me right now because I just got a job for the data engineer, but I'm not really experienced in Andre and Matt. Like when I was like listening, I was like, wow, shit, I cannot understand half of that. I have a quick question because my new client they hired me to make the automatic ETL process. But the problem in here is that currently they were using the Jupyter Notebook with the Python, but that process was manual because they were using the Python. So they were extracting the data from various databases that was like structured and unstructured data. Some of like SQL-based database, but some of them are no SQL-based database. So it seems like they made some Python codes over there, but now like they found that it's inefficient and they wanted to automate that. So they were thinking to automate this process by using whatever technology outside there. They're thinking about using the Azure service. But I wanted to ask your advice in this sense, like with the structured and unstructured data. That let's imagine the situation that you don't know what kind of data that is coming. What would you suggest, like in this sense? I am familiar with SQL. Python, yes, but I'm not sure, like if that is efficient. The process.
Yeah, I mean, I probably have some questions as well. But I mean, if they've written some inefficient ETL process that's currently run by Jupyter Notebook, it's automatable in Python. The fact that it's in Python is not the problem. And you could always take that Python process, wrap it in. Let's say that you decide to automate by introducing, let's say, Airflow to the stack. So Airflow is a workflow tool where you can wrap your Python code in what are called, or you can use operators directly. They're called operators. They're basically some pre-canned Python functions that run and do a certain task for you. And you can wrap your Python code and create your own custom operators to do things and chain them up together. And you can create these workflows that run based on triggers, or they run at specific times based like on a cron schedule. And you can automate that way. And you've got automation at that point, but you don't necessarily have efficiency. If you take inefficient code and you automate it, well, now you have automated inefficient
Mm.
coding. And in that case, you can definitely automate it and keep the logic that you have at the moment if it works, and that might be enough to please whoever is looking to change the system if all they're looking for is automation. If you're looking for efficiency, well, at that point you have to do an analysis of what is inefficient about the current process first and foremost before you make a choice of tooling or languages or commercial products to use to do this ETL process. And you mentioned that there's data coming from SQL databases and NoSQL databases.
That's right. That's right.
I'd also ask like what the target is. Where is all this data going? Because you have multiple sources. Is there a single target? Are there multiple targets? Which will dictate, I guess, your choice of tooling of technology. Do you have to transform it at all after extracting it? There's a lot there to I guess look into before a design can be suggested.
Looks like they developed some kind of a data warehouse that they can load it back. But that data warehouse, like they want to fix that one as well. My concern is about the unstructured data.
Okay. And where is that? So what kind of data are we talking about? How unstructured is it?
Yeah, I didn't start a work yet, so I cannot give more resources. But let's imagine like something like image or voice.
Image data. You know, that's probably the one data type that I haven't worked with. Is images. But I mean, if I had to think about images, I mean, it's binary data, right? I mean, unless I'm completely wrong about how images are stored, I would imagine that they likely are binary data with some compression applied. And yeah, in that case, I mean, it's you don't store images in a SQL database. I can tell you that much. That would be ridiculous. I don't even know if you can define a binary text column to store it.
I think you can store
You can store links to S3 buckets, and that's what.
Oh yeah, you can definitely do that. That's a more interesting way to deal with it. Yeah.
I think you can actually store images in Azure. Without a database with an image check. They didn't give it to us because it was labs, but I think you can do it. I don't know why you would, but yeah.
Yeah, you can definitely store pointers to images. That's also that's correct.
So I think it was like an image type. Like let me go.
Another fun tidbit for that I saw that I was actually pretty impressed with in along the same lines of efficient storage and so with financial data, I mean, you're often going to encounter most of the financial data is going to be what, right? You have money, you have various
Dates.
indicators of performance, percentages. A lot of data is going to be either strings or floats, and floats take up a bunch of space. They're more they take up more space than integers. So one thing that I saw exactly one company do that I thought was wow, that's a cool way to change to save on storage is instead of storing all of their money as floats, they instead multiplied by 100 and stored the cent value as an integer, and that took up less space than they would take by storing $100.04 as a float.
You only see one company do that. I feel like that's like the standard practice for storing things.
I don't see it as standard practice. I feel like a lot of I've seen it exactly once. It's storing the cents as integers or storing a lot of your money values as integers.
That's interesting.
I've only seen it once, and I was like, oh, that's a good idea. Just a little thing I wanted to share.
Awesome.
But if it's common practice, and I haven't been seeing it, then maybe I'm just amazed for no reason.
It isn't common practice in my bank because I need my pennies.
I'm sure the rounding errors do not work in your Okay. Yeah. So Sudman, I want to touch on a few things. So one of the things you mentioned is just like productionalizing a job, and so that's the easiest way to do that is just to pick something that does scheduling. So Airflow is something Andre mentioned, and it's definitely like an important tool. But there's so many other, basically any cloud platform is going to have a scheduling tool, and you just got to figure out how it works and implement it. In terms of NoSQL versus SQL, I am almost of the opinion that these two different paradigms are starting to converge very drastically. So let me kind of expand on this a little bit. SQL databases like Postgres and Redshift do allow for JSON operations. So you'll store a JSON operation as the actual object, and then you'll they have syntax enabled for manipulating that actual JSON object. That isn't a core SQL paradigm. It's actually like a NoSQL type situation where you have an object that you don't have any consistency on, and you kind of manipulate it. So that's very NoSQL. Databases like MongoDB have started adding different functions like aggregates and whatnot that perform very similar to SQL. In fact, if you go on like MongoDB, any sort of operation they have there, they basically show you the equivalent SQL statement. And in my mind, that's a little bit of a question of like, why are you implementing your new language, and why don't you just implement SQL native to your database? I don't know the exact answer for that, and I can't speak to their decision making, but I do think these languages are kind of converging. Generally, the benefit of SQL is that you have a lot more knowledge of the data coming back to you. And so if you have a column that has a type of not null, you know that value is not null. In NoSQL, you can include ORMs, object relational mappers, that prevent you from uploading a null object. But if someone directly interacts with your database, they can always overwrite that. So it's not at the database layer, it can be at the ORM layer and whatnot. And then the last thing that like the quintessential thing to like people always recommend for speeding up operations, which is a double-edged sword, is caching. It's a double-edged sword similar to like what regex is. There's a regex quote that like, if you have a problem and you go to use regex, now you have two problems. And if you ever work in regex, like you'll find that to be the case. You'll be like, oh, this is the perfect thing. Like all I'm looking for is a string within a text. This is gonna be great. And all of a sudden you get like 30 hits instead of the singular one you were expecting. And so that can be problematic. Same with caching. So the caching, caching is like a huge performance boost, because what you're going to do is if you computed the operation once, you just use that value. The problem there is cache busting, right? So how do you know once your value becomes, once your cache becomes either expired or it's too old to be valuable? And so that kind of becomes the problem. There are databases like Redis that are basically just databases associated that all they do is caching. But I think the biggest recommendation I have is trying to come up with some scope, and then basically setting good expectations about what your clients can expect, right? So if their thing is we want a week's worth of work, like your job at that point is less actually coding and then more kind of convincing them that a week's worth of work is not as much as they think it is, right? Whereas if they're like, we want a full-fledged solution, then you're like, okay, let me scope out what this would look like in its final state. And then when you have a good direction, trying to be as incremental as possible, right? So instead of refactoring the whole thing from in a new technology, being like, okay, let's first get it to run automatically, then let's get it out of a Jupyter notebook and into regular Python. Okay, then out of Python, let's figure out where we want some of this logic to exist and whatnot. Let's add a caching layer, and then you can slowly start to improve the performance there.
Does anyone know where the Databricks comes in here?
Oh, Databricks is well, they're a company that sort of made their name off of providing. Well, they provide ETL services, so they mainly work with Spark, I think, and they provide their own sort of Spark deployments that are pre-configured for you to use. I know they charge a lot for what it is, and the performance isn't even guaranteed.
And they also provide some. They're I think they're also active a little bit in open source. They provide various drivers and connectors for databases and other sort of tools. But their main goal is obviously to try to get you to buy their Databricks products, which it's going to be like. I guess the only one I'm familiar with is their Spark deployment, which is where they try to make it very easy for you to develop your whatever your ETL pipeline is to develop that within their environment within Spark. But that's the way that I know them.
Thank you.
Well, yeah, that helped drive a bunch of the conversations. I did want to address the YouTube comment for C++. I can't really talk about C++ because I haven't really worked in it. But I do think, I do have friends that recommend it, and I do think it's like a multi-generational language, which is a interesting thing about it. Not just interesting, like is a positive thing about it, and whatnot. But I do, from the languages I know, my recommendation is always Python as a good first language.
It makes things hard for you.
C++ or Python?
C++. It forces you to work.
You cut out.
Yeah. Andrew?
He'll come back in a second. Andre? You there, Andre? I'll message him.
Edwin?
I think everyone else is here.
Matt just wants to hear my voice. I mean, Tom just wants to hear my voice.
No, I was gonna ask you if you wanted to add something about C++.
He just gets anxious when I don't speak for a while. I don't know why.
Oh, that's good to hear.
C++ for data, not recommended.
No, of course not. For the first language. I mean.
That is like the first language.
Yeah. C++ for first language, also not recommended. Python is the way to go.
All right. Well, I'm sorry whoever wrote that on YouTube, but Python is the main choice of language here.
I don't know who that person was, but probably was trolling.
I doubt it. I'm sure they're just giving some good feedback. There are definitely like diehards in languages that would advocate for their specific language. All right, let's go through some tools at this point. At 8:30 at this point. Airflow is basically a way to schedule orders of operations in just about any language. So Andre mentioned that it has like a bash operator, and essentially if you have the code there and you have a bash command that'll call it, you can call it. And so it has this series of jobs, and then you orchestrate these jobs to occur in a specific way. Right? So if you want to make sure that you upload to the database before you read from the database, Airflow is that kind of tool. Some people just simply use it to schedule jobs periodically, because Airflow does have tools for that. It's a little bit overkill for that, but even there, Airflow is such a simple tool to use that like plenty of people successfully use it just for that and whatnot. Anyone have thoughts on Airflow? Let's wait Evan here. We get a lot more feedback.
Yeah.
Yeah, and we should link to his lecture on Airflow.
Yeah, we should definitely do that.
What's the name? I'm sorry, Edwin?
I mean, didn't you upload Evan's lecture on Airflow like from a few weeks ago?
Yeah.
Yeah, he had an intro, so we should.
Yeah, so it's not mean. You can take a look at that. I've never really worked with Airflow, but yeah, it's a good way of just automating your ETL pipeline.
Oh.
Yeah. DBT is a tool for somewhat similar to Airflow, but strictly for SQL. And what it does is allow you to organize all of your SQL code to be essentially either materialized views or ephemeral views, as they call them. And so they are essentially views that you can reference a table that either doesn't exist and is solely a reference to other objects or other computations. And so you're essentially defining these, they're virtual views, is what the SQL statement, the SQL version of it is. And so I find DBT as a good way for interacting with business logic within the kind of data engineering process. And that's generally where I kind of point people who are more operations side of people to look through for like operations, to add operations code. Spark and Hadoop, their whole job is to basically parallelize your code. So if you have one operation that can be done on many servers and you don't need access to like some global state, and by global state I mean basically other servers running your code, then it's going to be a good one. Hey Andre, you back?
Yeah, on my phone, because I guess the mobile client can connect, but my desktop client is just spinning in place and I can't do anything about it. So
it's unfortunate. Oh well, we're glad to have you back.
that's okay. It sounds fine through this as well. I just put my headphones in so I don't bother everybody.
Awesome. Yeah, we were just going through some of the tools. We talked about Airflow. I don't know if you have any thoughts. I just kind of went through the higher order of it, how it's a organizational tool for your what's called workflows, and basically picking, being able to create some precedents for jobs so that one job will occur before another job.
Oh yeah, I mean I love workflow. It's where I love workflow. I love Airflow. It's highly useful in sort of organizing your jobs that way and sort of creating this. Well, first of all, that's got a GUI, which is great because most of the ETL tools and code just kind of runs and you have no idea what's happening. So first of all, just from the standpoint of like, oh, this red and it was green, that's already great. Because you can see exactly what ran when, and it adds this whole 3-layer of monitoring to everything.
So I have a good, interesting question. So in my mind, Airflow is one of like, if you kind of visualize a stack where the things above know about the things below. In that context, I feel like Airflow is one of the things at the very top, right? Because as something that's responsible for scheduling things below it, you're basically should be aware of the entire ETL pipeline.
Mm-hmm.
And
yeah,
so,
I mean, yeah, it is essentially at the top of. I mean, the only thing that would sit above it is, I guess, whatever's managing Airflow, which could be like Kubernetes or something. If there was one layer above it, it might be that. Because whatever's keeping your services alive. But yeah, conceptually, there's nothing above it, and it's aware of, to a certain extent, it's aware of what's happened in the layers below it. If those layers communicate properly with it and have proper return codes and behave properly, then yes, it knows exactly what's going on.
I love how many times you've clarified with properly, in the sense that you're like, yeah, this is very unlikely to be the case that things are going
yeah,
properly.
I mean, if you connect it to something that's buggy, that doesn't really work, and mistakenly says, I've done my job, then Airflow would think that it's done its job, when in fact, it hasn't. So yeah, it has, unless you code it in, it has no ability to check the actual completeness of the tasks that it has executed.
Yeah. I mentioned DBT. It's essentially somewhat similar to Airflow, but strictly
yeah,
for.
I've actually never heard of it until now.
It stands for Data Build Tool. It's a program out of the company's out of Australia, which is probably one of the most interesting companies out of Australia. But basically what it does is it allows you to create DAGs, directed acyclic graphs, of your SQL statements, and then updates your SQL code along that way, right? So if you have, let's say one of your SQL tables is events, and then you want to define a table that builds off of that event. So you're an inventory management service. You receive buy and sell events, right? So buy means you got inventory, sell means you just sold inventory. what you can do is create a table that in a SQL table, a view that essentially computes off of that event store to figure out your current inventory, or that computes off of your event table to create like a current inventory table, right? And so a lot of these things can actually exist currently solely within SQL itself. Views exist within SQL. Materialized views also exist within SQL. But dbt does a lot of the orchestration of like what should be updated first. That's a big one. It also does this incremental thing where if you are able to filter out what is new, you actually can do incremental tables that are updated within incremental materialized view that are updated. And then it also has like a nice web interface as well that allows you to basically, let me even go to it, that it even allows you to view the order of operations for your tables.
Oh, Andrew, if you want, we have a video from Matt lecturing on that. I can send it to you if you like to.
Yeah, actually, I'd like to look into it. It sounds like a sort of it sounds like sort of procedures, honestly, with some sort of like triggers. So normally you have a DBA, you create the stored procedures, and then they'd be triggered in a certain way based on certain events, and they would update tables sequentially. But I guess that's the old world way of doing it.
So, can you see my screen? Can you see the graphic that I'm showing?
Yeah, I mean it's small on my iPhone.
Well,
Yeah,
so
I can see it.
this is a DAG, right? So essentially, what you do is outline like what gets built off another, and so you can essentially like these raw orders oh no, it probably goes the other way. So raw page views, raw page session eyes, right? So this table will be built off of raw page views, and it'll do some operations on it. And these actually can be just views in the sense that of SQL views as well. But what dbt does it's a way to basically update your code, to push your code to production, and to think about your views in this sort of DAG way. So if some of them are materialized views, they get updated before the further upstream. And so really, it's just like a way of pushing SQL code to your database.
Interesting. Yeah. I think what this offers is so I mean I think all of this can be accomplished today without dbt, but it's very it's hidden from view, right? You could definitely create this little DAG that you just showed, just using stored procedures, using triggers within your SQL frame or SQL database of choice. So that obviously that provides the option to create such constructs. You wouldn't have such a nice view of it. Like it would take someone a while to unpack everything and see, oh, this table is linked to this table through this procedure, and whenever this table is inserted into, this triggers these views to be updated. So everything is very hidden from view, and you can't really see anything in such a nice way.
So yeah,
definitely a nice tool of at the very least, a nice tool of convenience and of displaying all the relationships that exist between your tables and your views.
It also helps with the development environment in the sense that like if you want to start a Postgres database locally, you wouldn't get like a DBA to upload all these stored procedures, right? So you just run dbt, and it would upload all of your procedures to the database. And you could also provide seed data, and then there's a framework for testing, which testing in SQL is generally people pull testing out of SQL because I don't know the SQL framework for testing, but this will essentially either do validation or you can actually do snapshot testing, which I've done. And then you could also upload CSVs. So if you're like, okay, let me mock some data, and this is what I want to be my event source in my dev environment, then you could do that very easily. Whereas otherwise you'd have to like create like a SQL insert table, and then not only that, you'd have to make sure that you're truncating the table before you reinsert so that you don't get multiple of the same records. And so that's why I say it's like an orchestration tool. It's really like all the things it does can be done other ways. And even as I've used this tool, I've considered, okay, if I want to do this better, would I like fork DBT, or would I just start using the other tools that already exist out there? So I think it's a good tool.
Mm-hmm. What GitHub page are you on right now?
GitHub. So if you look up data build tool, you'll find
Okay.
it. DBT doesn't just post, and I posted the link in chat.
Yeah, so I mean, it definitely, testing is tough when databases start becoming involved, and not least because of I think one of the toughest problems is probably defining what your test data set is, and keeping that up to date so that you're covering all of your cases.
Yeah.
That's certainly tough. And also setting up the database each and every time that you want to run your test suite.
Yeah. Spark Hadoop, basically for parallelizing any code that you can. And so if you're trying to speed up your ETL program, the biggest thing you can do is parallelize your code. You can also throw bigger machines at it, but generally at a certain point, you're going to have a bottleneck. I've worked a little bit with Hadoop. Andre, you worked with Spark, right?
I've worked with both, yeah. Mainly within Amazon's EMR framework. That's the Elastic MapReduce framework. All it is really, it's just a way to scale machines up and down, and they provide their own distributions of Spark, Hadoop, other Apache, mostly Apache products that you can just sort of take in your CloudFormation template, and then they get deployed and configured onto the EC2 machines that you're scaling up and down. So it's a way to have a Spark cluster created and run stuff. So, but yeah, I've worked with Spark to handle jobs, and yeah, if you can, anything that you can parallelize, at a certain point, that's what you do with your ETL. Is you break it up into chunks, but you have to be careful, because if you don't have the right data size for it to be parallelized, then you're actually going to be incurring a performance hit. Like if you're trying to parallelize an ETL flow with, I don't know, let's say your data size doesn't really exceed 1 gig, and then if you try to split that 1 gig into smaller chunks and send it to Spark, you're probably going to be slower than if you try to just process it on one machine. So it can be a godsend for large data, but you can also be shooting yourself in the foot if you try to use it and you don't have the data size where the actual performance hit you take because of all of the Spark overhead. That's basically splitting the data set to multiple machines, and then basically bringing it all back together at the end. Those are all network performance hits. Those are that's time waiting for the orchestration to figure out what's going on with your data set, where it is, figure out how to do the whole planning step of your Spark workflow. So yeah, can be a godsend, can also really suck if you're deploying it wrong.
Yeah. So the way I would frame that is it basically divides your total time by a certain fraction and then adds a constant to it, right?
Yeah.
So that constant is the orchestration. How do you get it into everything? And
yeah, you better hope that constant isn't larger than your current runtime.
Yeah.
I think that it's hard to determine what that constant is, and where the magic spot is for, hey, we can move from this single machine Python process to Spark. It's hard to determine that, definitely.
Yeah. Elasticsearch, I threw this on there because you brought up indexing in databases, and Elasticsearch is like the premier highly indexed database. although MongoDB is actually their Atlas platform is basically they're trying to say that their indexing is as good. I can't comment on which one's better, but I know they're both kind of the things that get talked about. And basically, what indexing does is that you're storing a value, you're storing a reference to a more direct reference. So if you want to search for your people through your database by like first name, if first name was an index, you'd have a lot more performance. Or if it was one of your keys, your primary keys, you would have very high performance. If it was indexed, you'd have very high performance. If it's not, then you have to actually search through all your records and find all of the values. And so indexing allows you to not have to search through everything. And so it's like a database thing that definitely allows you to be more performant. ORMs. I thought we'd have more time to talk about this one. I feel like ORMs is a big one, whether to include them or not. I, for a long time, was a big fan of them, and I'm slowly moving away to thinking that you probably don't need them.
Yeah, I mean, I think their use. I'm a fan of them. I think there are certainly cases where it's just better off you're better off literally having raw SQL in your code and executing that and handling the data yourself than just putting that whole framework in, defining your classes to represent your rows, and then dealing with all of that stuff. There's definitely a place for them, though, I think.
Yeah, we'll have to disagree. I'll have to disagree with you, Andre and Matt, on this whole
What is it?
on this whole pushing business logic to the database layer. Let's just put it this way: it's a very controversial topic.
What's your stance on ORM, Edwin?
I like them. Obviously, you have to do a impedance mismatch, but logic should be written in object-oriented programming language or a functional language. Anything but raw SQL. That's I beg any.
SQL is a functional language.
Well, in a sense that don't do any crazy business rules and logic in SQL.
Look up, insert. Yeah. That's it. It's a CRUD app. We're done.
Yeah. Like, do not I beg anybody listening, please. Your life will be miserable if you start writing business logic in SQL. But yes, it is fast. Yes, it is a set-based language. Yes, you don't have to do loops. You shouldn't be doing loops. That all being said, it's not very pleasant to code in every day.
So I found ORMs to be less pleasant in SQL. I don't like coding in SQL. I don't like writing business logic is my argument towards that. But
I don't consider SQL coding. It's a query language. You're asking for a certain result set every single time you submit a query. I don't really see it as coding. It's more of like, here are a set of constraints, return all data that satisfies these.
Yeah, I agree with Andrew on that.
Well, first write like 1,000-line stored procedure in SQL and trying to implement a feature using multiple data tables, and I guarantee you it's not going to be very pleasant.
Yeah, I mean, you can definitely take like there's pure SQL, right, where you're issuing commands and saying, here, give me this certain data set. I think that I'm not very hardline at all on stored procedures. Or any of this other stuff that isn't really pure SQL. Because you can definitely go overboard with it. I mean, you can have stored procedures that trigger other stored procedures, and then you have this whole system that's just sort of hidden inside of the database, doing all the stuff in the background, sometimes not even efficiently. And it's also like, to your point, yeah, at that point, I guess it is coding in SQL when you're writing stored procedures to handle to handle a lot of your business logic, and that's definitely not pleasant because you don't want to be the guy who's just a SQL developer. That's not a it's a valuable skill set, but it really limits you in a number of ways. And unless you really love SQL, it's probably not going to keep you interested for very long.
Yeah, we're not talking about like jobs in SQL or anything. We're just talking about in terms of architecture. Like in terms of design pattern, you do not want logic. You do not want to be doing business logic inside the database layer. We have another layer called the logic layer, or the business application layer, or the application layer, and that's where we would do the logic, the actual algorithms and code with preferably an object-oriented language so we can use an object-oriented language to do so. So that's really what I'm saying. Like I just don't want people to get the impression that just because SQL is faster in a very micro sense, that you should be using SQL as much as possible. I think conversely, you should be using SQL as little as possible because it's just not very elegant for developing very complicated features and modules in. And also, of course, there's just a whole host of other things that we've innovated past writing SQL for everything, so I just think to try to regress back to it is it's not very pleasant. So that's just my 2 cents.
Yeah.
Yes.
Well, so I'll push back on a few things. One, I think SQL will always be around in the sense that even newer technologies are implementing solutions in SQL. Kafka implemented their streaming service, like the way you query for them is in SQL. It's a technology that's like only a few years old, and they decided that the easiest way to interface with their technology is through SQL. Two, I think you mentioned that the business application layer. I think if you go to like a microservices architecture, a downstream service will look like a database. And that service will be doing logic, but when I query from it, I just send a REST call and I get a response back. Right? So it almost feels like I'm basically interacting with another service, but it also sort of feels like a database with a some sort of web app or some sort of API in front of it. If that makes sense.
Yeah, you're not going to get away from databases or query languages. If it's not SQL, it's going to be something else. It's going to be Spark. It's going to be some JSON query language that you send over REST. It's going to be something. You're not going to get away from filtering, from aggregating, from doing all this stuff. The real question is, how can I do this most efficiently? And in that sense, I'm advocating for a combined arms approach wherever possible. Like for me, the question most often is, how can I do this in a way that one makes sense for me to sort of from a coding standpoint, from a future maintenance standpoint, and in a way that makes sense for the business. So for me, I'm not, I guess, a purist in the sense that I will keep all the business logic in the application layer. I'll put it wherever it's most efficient for it to be.
Do you have any rules of thumb on that?
I make extensive use of indexing of views, materialized views, and I think that stuff should remain in the database layer. Anything that is manipulating the data in a way that maybe is inefficient in SQL, I'll pull that out. It's hard to think of examples on the spot, but I do think that if you deploy a database system, let's say, like, for example, I'll use Vertica because I'm familiar with it, and we have, let's say you have a 12 node deployment of highly powerful machines running this, and your data's already there. probably already caught in memory. I think it's great to make use of that and have the database do a bunch of the heavy loading on whatever operations you need to do on the data before it's sent to the application layer. That's just me. I do think you can go forward with it, but as long as it's efficient, it doesn't really matter to me whether it's elegant or whether SQL is maybe outdated.
You guys want to see a puppy?
Yeah. Oh my god.
Wait, you have a puppy?
Public. Yeah.
Oh.
Hold on.
That's the best way to quarantine. Alright, she's she's that.
Wait,
Yeah. Best way to quarantine with the dog.
Wait, I still see this this Google Doc. Where is the doc?
Oh yeah. If you're on like a
Oh wait, yeah, I'm on.
there's multiple screens.
Oh yeah, okay.
Dog left. Sorry.
Makes sense.
I feel like a lot of these we can touch on later. I feel like the architecture thing would be a nice for a good conversation later. The data interchange formats. I was very interested to talk about Arrow because I have no idea what that is, and it just seems like the way you mentioned it, Andre, just sounded. I'm like, this seems like a tool that's gonna be cool.
Yeah.
Arrow.
You want
I can talk about it a little bit. I mean, everybody can obviously Google it and start reading about it a little bit. So I mean, it's an Apache. I think it's Apache Arrow. It's an Apache product, incubated probably. What it is what it solves is the following problem. So you have all of these tools for ETL, different systems that store and otherwise manipulate data, and they all do so they have their own way of storing that data and transmitting it, and you often have to write your own connectors between. If you're trying, like, let's say, and I'm gonna maybe mess up the names of these. Let's say you're trying to have Apache Kudu. I think that's a thing. Talk to Spark or talk to Zeppelin or something. You're trying to transfer data between these different systems, maybe because one system is better at doing this one thing than the other one, and you're willing to incur the cost of transferring the data out of that system just to do that one operation. You're going to find that you're going to have a hard time just basically manipulating that data and transforming it into the format this other system expects. So the way that they're trying to get around this is basically by defining this data interchange format called Arrow, which is just a way to structure data in memory and also a protocol for transferring it between systems. And so the theory is that if all of these disparate systems implement Arrow or use Arrow as their storage format, then that problem goes away essentially, because everything can talk to everything and they're all speaking the same language. And so if all you need to do is ask the system for its data, and it'll send it in a format that is understood, and that doesn't involve any input from doesn't require rather any input from the programmer in terms of defining the connector and defining this whole pipeline of how does data get from one system to another.
So my like one thing about that is this XKCD comic. Where
the standards comic. That comic definitely holds true unless there's actual agreement among people to accept that standard as the standard, right? Because the comic implies that like nobody accepts that new standard and it just becomes part of this group of standards, right? But there's broad agreement within the Apache community, at least, to use this.
That's good.
And that maybe is also a problem because it's within the Apache community. So like anything outside of that maybe won't implement Arrow. But it turns out that a lot of the Apache products are in wide use within the data engineering community and within data in general. So if it gains traction within that, then it might be forced on other things as well.
Well, so I definitely believe that standards can actually propagate. My favorite coding language, JavaScript, is a language that the reason I think it's successful is because it was implemented by every single web browser separately, and all these different web browsers essentially have to eventually agree on how to implement JavaScript or what the standard for JavaScript is. Basically, creating the Mozilla Foundation, which leads the whole effort. And I think that's why JavaScript is literally like one of the easiest languages to like introduce a new paradigm or introduce a new coding style or decorators and things like that, or even before they were adopted into the mainstream, have been like you can just get Babel to add a way to include it. But that's interesting. I'll definitely give Arrow a look. The last thing in tools was Excel, the spreadsheet. I actually think this might be an interesting conversation as a separate one, simply because a lot of people have used Excel. Very few people have used spreadsheet, and I think I'm actually one of the few people who's generally adopted spreadsheet first. So maybe at another point we can actually have this. Maybe we'll have like conversations where it's this tool versus this tool, and have people defend, right, to use an ORM or not to use an ORM, and then we can actually debate that whole thing and have and flesh out all the tangential things. But I do think now is kind of a good point to stop. We haven't gone through everything in this list. A lot of these things will generally just kind of come back up.
It's a big deal. There's no way we can go through it in 2 hours.
Oh yeah, absolutely. Most we're not here today, so that's unfortunate.
You cut it out for a segment.
I'm saying that the two people who wanted to talk about this the most were not here today.
Wow.
So
Okay.
we'll definitely kind of retouch on this topic at a future point.
Which
and
topic?
whatnot. Just general data engineering in general, and having like how should you think about your data engineering process? Let's say you have to do it from the ground up, or let's say you joined an organization where you want to do like major, be like a leader in that organization. How should you actually like think about these things? We sort of touched on that. We've stayed a little bit more in the concrete realm of actually talking about things and tools. We didn't go into the high and mighty of like, how do you change organizations? How do you like lead an engineering team, which could also be possible ways of doing that. But
I think that's a distinct conversation from having a technical conversation about how do you build data.
Oh yeah,
because that touches on people, leadership, and you'd also have to discuss sometimes your lack of power as an engineer. Like there's definitely situations and places where you're not going to be able to do anything, and you have to like recognize when and where that is.
Absolutely. Okay. So just generally, just kind of to summarize today, we kind of we had Edwin's LeetCode thing, which was an interesting one, and then we kind of went through these topics. We'll kind of send a summary out later of what we talked about, and then in general, I like these discussions a lot. I think they're a lot easier to kind of talk to a group as opposed to if you've ever had to kind of present to people on mute. It can be a little bit intimidating, whereas this is a little bit more back and forth. So I think for a little bit, we're going to stick a little bit more to discussions, and hopefully we can kind of come up with a good one for next week. If anyone here has any suggestions on it, definitely reach out. If anyone's watching on YouTube and wants to join, we have information on Discord, and you can feel free to join us.
Yeah, like and subscribe.
Yeah, like and subscribe. The button is the button. Where's the button?
It's here.
Yeah, just point the whole 4 corners. You'll get it right.
Yeah. All right. Well, thank you everyone for joining. Thank you everyone who's kind of been coming week to week. It's always a pleasure. So, thank you and have a good night.
Thank you, guys. Thank you, Andrew. Thank you,
night.
Sammy. Bye.
Good night. Thanks, everyone.
Yo, Mo, say something. Are you there, Mo?
She's still here.